trend. Okay, so how do I write for this function the increasing and decreasing intervals? Here's how I write them. If I can get to the next page. Okay. So, for this function, let me show it here so you can see it better. So I will say this. F is increasing on -4 to 0, not from what to what? From x being -4 till x being 0, with parentheses, union, because there is another interval, from this, I'm going to say 4, from 4 to 6, also open interval. And f was decreasing from the moment it hit 0 till the moment it hit x equals 4, on 0 to 4. No brackets anywhere. So why is this such an important property? It tells me the trend. If you look at the stock market, if you look at temperature for a patient, and so on and so forth, you want to see the trend. It went up from the moment, the temperature went up from the moment a patient arrived at the hospital, for the first 10 hours, for the first 3 hours, for the first 4 hours. And then it started decreasing for the next 2 hours. We do not, when we talk about increasing, decreasing, we don't talk about y values, only from left to right. Now, there is something called relative max min, also called turns. If you remember, when I put the arrows, it goes up and then it turns, coming down. And then it gets to this point, it turns and it goes up. So this point is a relative max. Relative are also called local. In some books you're going to find that they are the same. Relative or local. A relative max. Because all the other values here are smaller. Now I'm talking about the y value. And obviously this is a relative min. The function decreases, reaches a low point or a turn, and then goes up and increases. Any questions? Any questions on these properties? A lot of properties, right? Domain, range, x and y intercepts, increasing, decreasing, intervals of increasing and decreasing, and relative max min. Any questions? Any questions? Okay, I'd like you to make up a function, any function you want, so we can evaluate it. We want to review how to evaluate functions. Can anyone give us any function that you would like us to evaluate, and we will evaluate it? Anyone would like to pick a function? Anyone?
8.
Well, we want a function to evaluate. A function that is y equals 8, there is nothing to evaluate. I'll make one up. -2x squared plus 4x minus 3. Just for the sake of the argument, can anyone identify this function for us? What is it? What type? I'm sure it was discussed in chapter 1 a lot.
A trinomial?
Yes, it is a trinomial, but because the degree is, what is the degree?
3.
Careful.
2.
Yes, yes, the degree is 2, so it's quadratic. It's a quadratic function. Now let's say we want to evaluate it for 0 and for -2. What do I have to do? What is the idea here? Because then I'm going to ask us to evaluate it for x plus h. So before we do any of this, if you give me this function and you ask me what do you see, what do you see? What is the pattern you see? I will tell you what is the pattern that I see here. The pattern is this. So this is the same thing, but it tells me that if I want to evaluate it for whatever, I have to take the whatever and square it, then multiply this quantity by -2, and then add 4 after I multiply it by whatever, and subtract 3 at the end. So this is the order of what I'm going to do anything. If you want me to evaluate for 64, I will say 64 squared, multiply by -2. I will multiply 4 by 64, add the answer to what I got in the first step, and then subtract 3. So again, the pattern is f of whatever is -2 times whatever squared plus 4 times whatever minus 3. Once I understand the pattern, oh, this is a piece of cake. Because f of 0 will be 0, 0, -3, and it's done. F of -2 requires a little bit of calculation. I'm going to copy the -2. I'm going to replace the whatever with parentheses, because it's a negative number. Put the square on it, plus 4. With parentheses again, replace the whatever by -2, and then -3. Yes, of course, I have to apply the order of operations carefully. -2 squared is +4. +4 has to be multiplied by -2, so I get -8. I have another -8 and a -3. They're all negative. I add them up, I get -19. So in this case, the ordered pair is 0, -3. Can anyone give us the ordered pair for the second situation?
-2 minus 19.
Exactly. Very good. Awesome. -2 comma -19. What do I do here? Don't get scared. Exactly the same thing. There is no difference. So I'm going to copy -2. I'm going to copy the whatever in parentheses, put the square on it. I'm going to copy +4. I'm going to copy the whatever in this format, of course, because that's the whatever, and then I'm going to copy -3. Yes, this needs work, because it's not fully simplified. That's okay. But it's the same pattern. Once I have the function and I understand the pattern, no one can, take me away from it or make me see something else. The pattern is here. No one can change that. -2 times whatever squared plus 4 times whatever minus 3. And this is what I did for f of x plus h. Now, I have -2. I have to square this binomial. Anyone remembers how to square x plus h and how many terms we get? How do we square x plus h and how many terms do we get? Anyone, please?
It's x plus h times x plus h.
Yes, so, and the answer is? Yep, we want the whole thing right away. We want to stay away from foiling. We already know the formula. So here's the formula again for you. It's a different formula. So this is, I'm sorry, I meant to write a plus b. Doesn't matter. So this is the first term squared plus twice the first times the second plus the second term squared. First term squared plus twice times the first times the second plus the second term squared. We want to stay away from foiling. We did foiling in the beginning algebra. We are in college algebra. We want to be a step ahead. So, keeping in mind that what we have is x plus h squared. Can anyone give us the h plus h squared?
Would it be x squared plus 16x?
So this is h.
Oh, that's an 8?
Yes.
Oh, I thought you said 8. So would it be 2bh? Oh, xh, sorry. Plus b squared?
You mean h squared. So we have a is x, b is h.
Oh, h squared then. I'm sorry.
So that's okay. So we have x squared plus 2xh plus h squared, and now we distribute plus 4x plus 4h minus 3. Final step, because you'll see we cannot combine anything like terms. I have to distribute now. Do not distribute first. There will be a terrible mistake. You have to apply the power and then multiplication. Do not distribute -2 and then square. That will be a terrible mistake. I'm not saying you're going to do it. I'm just talking about it. So now I can distribute -2x squared minus 4xh minus 2h squared plus 4x and plus 4h and minus 3. And that is it. So what did we just review here? We created a function and we wanted to evaluate it for different values like 0, -2, and x plus h. And you will see why this is so important, f of x plus h, in a minute. Any questions? Any questions on any of the steps? Let's take a moment and see if we have questions. Please, anything.
Is that how we solve it every single time? Or
Every single
time.
Every single time for forever and for good. Yes. If you have
Yes,
to
ma'am,
square,
okay.
yes, if you have to square a binomial squared is always a trinomial. Two terms, when we square a sum or a difference of two terms, so let me also correct this, not correct, but if there is a minus here, then you have a minus here. That's the only difference. Any binomial that we square, we have to come up with a trinomial as the answer. A binomial, 2 terms squared, 1, 2, 3. 3 terms as the final answer. Any questions? Any questions? There is a very important topic called piecewise defined functions. What is a piecewise defined function? I'm making stuff up right now as an example because I don't know the percentages. So here's a piecewise defined function, an example. Let's suppose somebody who earns between $0 and $40,000 per year pays 5%. As I said, I'm making up numbers. I don't know if that's the case. Somebody who makes from 40,001 to 60,000 per year, the tax code says you have to pay 6%, and so on and so forth. This is a real life, not with the correct numbers, but it's a real life situation. This is the tax code. Before April 15th of each year, we calculate our income. We use whatever we use, or an accountant, and the accountant says because you made this, you have to pay 5%. You have made this, you have to pay 6%. You made this, you have, this is a piecewise defined function. So now we're going to look at an example. We're going to evaluate it and graph it. So I'm going to make one up. Let's say 2x minus 4, 4x less than 2, and let's say negative x plus 1 for x greater than or equal to 2. I chose a function that is a piecewise defined function, is defined in pieces, and I chose 2 pieces. Can I have more than 2 pieces? Yes. This one has many. But I chose a simple function with a piecewise defined function that is defined in 2 pieces. First of all, let's evaluate it. And I'm going to pick few x values. I'm going to ask, let's find f of negative 2. Let's find f of 0. And let's find f of 2. And one more. Let's find f of 3. So this is our piecewise defined function, defined in 2 pieces. The pieces cannot overlap. If they overlap when we graph it, this is not a function. They cannot overlap. As you notice, x here is from negative infinity to 2, negative infinity with a parenthesis. But here is from 2 with a bracket to infinity. So the 2 pieces cannot overlap, like here. You cannot pay 5 and 6%. You pay 5 only from here till here. You pay 6% only from here till here. You pay 8%, so on and so forth. They have no overlapping. Okay, so let's identify and find these values. F of negative 2, f of 0, f of 2, and f of 3. Can anyone suggest what to do with f of negative 2? Where do I plug it in? We have to make a decision, because I can only obtain one y value, not more than one. So is it in this piece or is it in this piece? And why? Can anyone help?
Is it the second option?
So negative 2. Is negative 2 here?
No.
No. Is negative 2 here?
Yes.
Yes. We plug it in. 2 times negative 2 is negative 4. Negative 4 minus 4, negative 8. Any questions? We cannot plug it in here because negative 2 does not belong here. It's not a number greater than or equal to 2. F of 0. How do I find f of 0?
The top one?
Of course, because 0 is here, and it's not a number greater than 2. Brilliant. 0. 2 times 0 is 0. 0 minus 4, negative 4. Excellent. F of 2.
The bottom one?
Yes. I cannot put it here because it's a parenthesis. I must put it here because it's the equal symbol. Negative 2 plus 1, negative 1. Excellent. Final one, f of 3.
Bottom one?
Yes, of course, it belongs here, not here. So negative 3 plus 1 is negative 2. Awesome. Great job. Any questions? Let's take a moment and see if you have questions, please. Anything. Any questions, or is this okay? I hope I didn't lose anyone. Any questions? Okay, now we want to graph it. Graph f of x. I'm going to copy it here so I can remove this. 2x minus 4, 4x less than 2. I'm going to copy that too. It's very important. And I'm going to copy negative x plus 1 for x greater equal to 2, and I'm going to copy this interval. Perfect. When I'm asked to graph a function, my first thought always is domain. That's my first thought, always. And I get a table going from the very beginning. I personally prefer horizontal tables. You can use a vertical table. It's up to you. It occupies much less space, I think. Anyway, another reason. Good. So, can anyone tell us the domain of this function? Of this function, of course. And you should look at this, and look at this, and say, I know the domain is, give it a shot. What do you think? The domain of this function. It's okay if you're wrong. What do you think?
Two.
The domain. The domain is all possible x values.
Minus infinity
to
to 2
minus infinity to
to minus to infinity.
exactly. Negative infinity to infinity is indeed a domain. There is nothing missing for this function. It has all the x values to the left of 2. It has 2 and all the x values to the right of 2. Now 0 has to be in the table at all times. The other super important value here is which one? Look at what we just wrote here and say, oh, the other important one is this value. Yes. Why is that so important? Because it's like the threshold, right? Something happens before 2 and something else happens after 2. I am going to copy right under 2 these symbols, and they will be touching. This symbol to the left, opening to the left, and this symbol touching to the right. Because they are both on the left-hand side of 2 and on the right-hand side of 2. I will make myself a note that between negative infinity and 2, between negative infinity and 2, I have to use this expression. I make myself a note that between 2 and infinity, I have to use this expression. They are both linear functions. I chose the simplest possible example. Let's plug in 0. When I plug in 0, and we already calculated it on the previous page, we had one of them was 0. F of 0 is negative 4. Can anyone plug in 2 here? And you should say no. You should say no. No? Why are you forcing me to plug in 2 here when 2 is not in this interval? Why? I'll say for a moment, trust me, and plug in 2 here and tell me what to write, and I will write it right here inside the parenthesis. When you plug in 2, what do you get?
0.
Thank you very much. Bear with me, although the answer should be no. But if you don't want to plug in 2, then you will have to plug in 1.999999999999999. Do you want to plug in 1.99, or you want to plug in 2 and leave it as an open point? You don't want to plug in this. So I'll explain in a second. Let's go to the other side. Can anyone plug in 2 and tell us the answer? Because now here I am allowed to. Can anyone plug in 2 and give us the answer?
-1.
Excellent. Right inside the bracket. And we have to choose one more. Can anyone plug in? And you say, yes, we just did that 5 minutes ago, and it's negative 2. Now I'm ready to graph. So, 0, negative 4. So 0 for x negative 4 for y, 2 comma 0, but I have to be careful because this doesn't really exist. It's an open point. And I will connect and extend to the left only. Okay, you don't have to use two different colors, but I'm making a point. Okay, I drop that color to negative 1 and 3 comma 2, negative 2. Again, if you extend by mistake this function to your right, and if you extend this function by mistake to your left, this is no longer a function. By the vertical line test, it will not be a function. So they can, the branches, the 2 branches or 3 branches or one, as many as you want, of a piecewise defined function, because it's a function, you have to show that by the vertical line test, this is a function. If you continue, that will no longer be a function and it will be incorrect. Final question here. Can anyone give us the range of this function? Yes, we identify the domain, we put it in the table, all real numbers. But can anyone help us in finding the range of this function? Exactly how we did it a few minutes ago.
Zero, is it 0?
Careful, careful. For the range, we start as low as possible with horizontal lines.
Minus infinity
Yes?
to 0.
Exactly. Negative infinity to 0. I have to use a parenthesis because the point does not really exist. Excellent. Any questions? Any questions? There are other methods of presenting this. I rarely say that my method is the best, but in this case, I truly believe it is. You can use other methods, of course. However, other methods with separate tables for this and separate table for this may or may not tell you what to do here. So obviously this is an open point, and obviously this is a closed point. And you see it 2, negative 1 is a full point, and 2 comma 0 is an open point. Any questions? Any questions for me?
Hi there. How do you determine what side gets the bracket and open
Excellent,
part?
excellent, right here. Excellent question, Michelle, thank you. There is no equal symbol. There is an equal symbol.
Thank you.
Is that okay?
Yes.
The equal symbol is always a bracket, and it includes the point. The non-equal symbol cannot include the point and is always a parenthesis. So I changed this into an interval notation. I changed this into a corresponding interval notation so I know which direction I put the parenthesis and which direction I put the bracket. Excellent question. Now if I had here the equal symbol, then I would have had the brackets facing this way and the parenthesis facing this way. The reason why I write above here is because I don't want to go back here and by mistake put 0 in here. It's possible. But if I see it here right in front of my eyes, then I will not make a mistake. So when I go with 0, who knows, maybe by mistake I go here. But that would be terrible. But if I have it stabilized in front of me, re-emphasized in front of me, then I should not make an error. Because it's right here. I'm not going back to the previous page, right? It's right here. I put in 0, I get negative 4. I put in 2, I get 0. I put in 2, I get negative 1. I put in 3, I get negative 2. I have to say, although I'm sure you understood this, a lot of people have difficulties with a piecewise defined function. Why? I don't know.